Suppose that a particle moves along a straight line with velocity 11 minus 6t in meters per second. Find the total displacement and the total distance the particle has traveled from t equals 0 to 13 seconds. Remember that displacement is how far you end up from your starting position and maybe positive or negative. Distance traveled is always positive. It's how far you actually move during your trip, whether forward or backward. Okay, and they want both those. So here's what we do. These are a little tricky. So step one, find S equals the position formula. Okay, so remember the relationships that exist. So you have position, which we call S for some unknown reason to me, and then V, which is velocity or speed, speed with a direction, then A, which is acceleration. We're not going to really need to deal with acceleration on this problem. And then this is by derivative, right? Derivative of position is velocity, derivative of velocity is acceleration, and then vice versa, antiderivative. So you go anti this way and anti that way. So anyway, my point is if we want to get S, which is what we want, we've got to take velocity, take the antiderivative, and that'll give us position. So we're going to take the velocity equation, which is 11 minus 6t, and we're going to do the antiderivative, which will get us the position equation. So the antiderivative of 11 would be 11t. And the antiderivative of this, minus 6t. This has a 1 power, so add 1. T squared divided by 2. Right, that's how you do the anti, you know that. So it'd be 11t minus 3t squared. So there it is. There's the position equation. That's step number one. Step number two, find the position of the particle. Whoops, a little crazy. Particle at t equals 0, which is where the particle starts. Um, when the particle stops, which is that means velocity is 0, and t equals 13 at the end. So you want to find those three key positions. Find the position at the start, the end, and in between when the particle stops moving for a split second. So where is it at the start? Well, that's going to be, you're going to take the S equation. We're going to plug in 0, the position at time 0. So take this equation right here, plug in 0. So 11 times 0 minus 3. Whoops, I didn't make that squared. Made that kind of weird, huh? Where was I? 11 times 0 minus 3 times 0 squared. So that's just 0. That's easy. Okay, and how about at 13? That's at 13. Well, here, actually, let's do the in-between first up. So in between, we got to find when's the velocity 0. When is that? When is velocity 0? Well, you got to take the velocity equation right here. Velocity, which is 11 minus 6t, and set it equals 0. Find out when is that thing 0. So if I move the 11 to the other side, so I get minus 6t is minus 11, and then divide by minus 6. And we get t equals, you're going to take the 11 divided by 6. Do that a little bit better. You'll get, we can go to Desmos, 1.8333. Show you right here real quick. There it is, 11 over 6, 1.83333. So, okay, so that's when the particle stops. So we need to find the position of the particle when it stops. So S of 1.8333 equals, plug into the S equation right here. It's the 11 times 1.8333 minus 3 times 1.8333 squared. Just plug into that S equation, and that's going to equal, so let's go to Desmos. So 11 times that minus 3 times that squared. So 11 times the answer minus 3 times that answer squared. Is that right? 11 times that minus 3 times the answer squared. 11 times, yeah, 11 times that time minus 3 times that answer squared. Yeah, that was right. And so what did Desmos tell us? 10.08 with a bunch of threes. So, whoops, 10.08. And that's going to be meters because that's a position. This also, the zeros meters. Okay, and then lastly at 13. So let's plug in 13. Find the position at 13. So again, plug in into this position equation. It's going to be 11 times 13 minus 3 times 13 squared. So 11 times 13 minus 3 times 13 squared minus 3 times 13 squared. Minus 3, so 11 is 13 minus 3, minus 364, minus 364, minus, and that's again meters. How do I know these are meters? Because in the beginning, it told us meters per second. So the velocity equation, the position is meters. So, okay, so what have we done so far? So step number one, we found the position equation by doing the antiderivative. This tells us the position of the particle at any time. Let me write that. Position at any time. That's what that equation is, this equation right here. Okay. And then we used it to find out what's the position of that particle at the start at t equals 0. It's at 0 meters. And what is the position when the particle stops? 10.083 meters. And then what is it at the end? Negative 364. So now step 3 is going to be all about making a nice little map. Map the travel. What do I mean? Well, the thing starts at 0 and then it goes to 10.083 meters. So it's going to do a little map here. So it's going to start here at 0, right, at time 0. And then it goes to the right and stops at, where is it? 10.083. Wait, with a bunch of threes. Meters to the right. That's a positive to the right, positive. At what time? What time is it? 1.83. That's time 1.83333 seconds, right? Because that, how do we know? Because that's when the particle stops. Remember, we took the velocity equation and we set it equal to 0 and we solved for time. We found out the time when the particle stops. And then we plugged that time into the position equation and found the position when the particle stops. So here's where the particle stops at the time. At the time, what time? 1.8333 seconds. And this, of course, is meters. So it ends up 10 or so meters to the right at 1.833 seconds. Now, where does it end up after 13 seconds? At negative 364. So then it comes way back, it must turn around, come way back here, end up at negative 364 meters, and that's at t equals 13 seconds. So that's the travel of the particle. Do you see how we figured that out? It starts at 0 and then it goes to the right. How do I know? Well, because it ended up at positive 10.08 meters at 1.833 seconds. And why was that an important time? Because that's when it stopped. It stopped going to the right and turning going the other way. How did we know? We took the velocity. That was step 2, when the particle stops, meaning when the velocity is 0. So we took the velocity equation equal to 0, solve for the time, found out what time, then plug that into the position equation to find out where it's at that time when it stops. So it's 10.08 to the right when it stops at 1.833 seconds. Then it must go to the left. How do I know? Because I know it ended up negative 364 meters to the left at 13 seconds. Okay, so now we can answer the questions easily enough. First question is total displacement, meaning this displacement, oh, there's not a C in there, huh? I'm just being weird with that. Yeah. It's disk placement, displacement. That is the end minus the start. Just how much did it move? In other words, it's just the end minus how much, so it ended up at negative 364. It started at 0. So the final displacement is negative 364 meters. When all was said and done, from start to end, from 0 seconds to 13 seconds, it ended up 364 meters to the left, negative 364 meters up from where it started. That's the final displacement minus 364, and that's what they got. Now the distance, what's the total distance traveled? Well, that's a little more subtle. Distance traveled, well, we know it went 10.08 to the right, 10.08333 to the right, and then it went from here to here. It must have done that 10.08333 again back. So add that again, because then it did that to the left to get back to 0. And then it did this last leg of the journey right here when it went all the way to -3. So this must be 364 meters because it goes from 0 to negative 364. So 364. And so we just need to add all those up. 364, 10.08, 10.08. Okay, so I'm going to take that 10.08 number, 10.08, 3333333. I'm just going to go times 2 because there's 2 of them, plus 364. Total distance 384.16666. 384.16666. Yep, there it is. We got the right answer. That's the total distance traveled by the particles. Again, how do we know that? Well, looking at the map, it went right 10.083, left 10.083, and then from 0 to negative 364, that's 364. So we added up 10.083 twice, right and then left, and then 364 to the left for the total distance traveled, which is different than displacement. Displacement just means how far did it go from where it started to where it ended. It ended 364 meters to the left of where it started. But it traveled to the right and the left and then did that. So the distance was greater. And so that's how we do it.